This is 8.6. This is solving rational equations. So now we're going to put everything that we've been doing kind of into one big thing, and we're going to be solving for these. So the objective today, students will be able to solve rational expressions. And this is the biggest thing I want you to know. This is the hardest part of the whole lesson today, and this is what is going to be the biggest pain. But once you get this down pat, hopefully you guys kind of do have this down pat. Once we start going, you'll know what I'm talking about. But the biggest thing to solving rational equations is getting all the denominators the same. It's really the same thing as finding common denominators. And it's a little bit more work with some of these, but that's the concept. So again, it's another one of those lessons where really you know how to do all the hard stuff we're doing today, you know how to do. There's a lot of factoring, there's a lot of multiplying, combining like terms, same thing we've been doing. All the new stuff isn't too bad, but the stuff that is the hardest in this lesson is all that stuff we've been doing. So make sure you're getting good at that factoring and finding common denominators and stuff. So this is just kind of an example of what we did before. And so what I did before is I found between 2, 4, and 8, I found the common denominator of 8, or the common multiple, and so I multiplied everything by 8. So I have x over 2 plus x over 4 is equal to 1 over 8. I'm just kind of spacing it out a little bit. And then I multiplied everything by 8. So everything, every one of these, I multiplied by 8. So the reason I did that is because now 8 and 2 can cancel. 2 divided by 2 is 1. 8 divided by 2 is 4. So now all we have is 4 times x. Then 4 divided by 4 is 1. 8 divided by 4 is 2. So now we have 2 times x. Then 8 divided by 8 is 1. 8 divided by 8 is 1. So 1 times 1 is just 1. And then we would solve this. That's 6x is equal to 1. Divide by 6. We get x is equal to 1/6. So that's the way we've done this in the past, but right away I'm going to kind of show you guys what I'm going to try to get you guys to start doing, and it's really the same thing. It's really the same steps. The only difference is when we multiply everything by 8, I'm going to show you kind of why we're doing that. So it's the same stuff, I'm just going to do it a little bit differently, and this is what we're going to be doing today with our rational expressions. So let me rewrite. We have x over 2, x over 4 is equal to 1 over 8. Now let's find common denominators just like we did before when we were doing the other rational expressions. So let's try to get all our denominators to be 8. Well, that means I have to multiply this denominator by 4. 2 times 4 is 8. Well, if you multiply the bottom, you have to multiply the top by 4. Same thing over here. I need to multiply this bottom by 2. Well, if I multiply the bottom by 2, I have to multiply the top by 2. Sorry, I should have crossed that 4 out. And over here, it is 8, so we just multiply the top and the bottom by 1, or we don't have to multiply by anything. So now when we go through, we have 4x over 8 plus 2x over 8 is equal to 1 over 8. Once you have all the denominators the same, and this is what I was talking about, once all the denominators are the same, we can go ahead and forget about them and just put all the numerators equal to each other. Just write it out with just the numerators. 4x plus 2x is equal to 1. Again, that's where you get the 6x is equal to 1. So x is equal to 1 over 6. So that's the way we're going to be looking at these problems. Trying to multiply, trying to get all the denominators the same. Once they're all the same, we put all the numerators in the equation. We just forget about the denominators. So for this one, we have 2 over 3 plus x over 6 is equal to 8 over 1. And if you look, we have a 3, a 6, and 1. So I'm going to try to get all my denominators to be 6. I think that's the least common multiple. So I'm going to multiply this one by 2, but I've got to multiply the top by 2 as well. The second one, we don't have to multiply that by anything. The denominator is already 6. And this one, we have to multiply by 6. 1 times 6, so we have to multiply the top by 6. So we end up with 4 over 6 plus x over 6 is equal to 48 over 6. Now that all our denominators are the same, we can start with 4 plus x is equal to 48. Subtract 4, x is equal to 44. That is our answer. So a little bit different than what we did. It's really the same math. It's just kind of a different way of explaining it and kind of setting it up. But that's what I want you guys to think about when we're doing these other problems, because that's really, if you follow those, it's going to get more complicated. I'm not doubting that. I'm not saying that. But that is the new stuff we're learning. Get all the denominators to be the same, just like we were finding common denominators earlier, and then all the numerators you're going to set equal to each other. So now these next ones are kind of pretty much the same thing, but we're going to be working on in the denominator. We just have numbers. We don't have any variables yet in the denominator. And like I said, it's really the same thing we've been doing. So put this over 1 to make it a fraction. And what's the least common multiple? Well, between 5 and 2, really the smallest, the least common multiple, or the common denominator, would have to be 10. So I'd have to multiply this bottom by 10, or sorry, by 2. Wrote the right thing, said the wrong thing. Multiply the top and the bottom both by 2. This one, I have to multiply the top and the bottom by 5. And this one, the top and the bottom multiplied by 10, because we want that denominator to all be 10. So 2 times y is 2y over 10. 5 times y is 5y over 10. And 7 times 10 is 70 over 10. Again, now that all those denominators are the same, that means we can just forget those and look at our numerators. 2y plus 5y, combine those to get 7y. Divide both sides by 7, y is equal to 10. Now technically you could sub 10 back in there and solve that. Sometimes this one wouldn't be too bad. 10 divided by 5 is 2, 10 divided by 2 is 5, 2 plus 5 is 7. So this one wouldn't be bad. Some of them might be a little bit worse, but if you need to check your work, plug that in, use a calculator. That will help some of you guys, especially because, like I said, some of you guys on the last test had 30, 40 minutes left at the end of the test, or 10 or 15 even. If you go back and check your work, that'll help. So this one, now we have 3 different fractions, or I guess 4 if you're counting what it's equal to. So we have a 3 and a 5. I'm going to put all those over 1 to make them fractions. And I want my denominators to be 15 for this one. That's going to be the common denominator, or the least common multiple. And one thing I will say that will come in handy with the other ones, if you ever see a minus, I'm going to change that to a plus and then put that minus up with the numerator. Same thing we did when we were adding and subtracting rational expressions. I think that really helps. And so I'm going to do that every time I see a minus sign. I think that's going to help me. So to get 15 in our denominator, I have to multiply the top and the bottom by 15 over here. This one I have to multiply by 5, top and bottom. Let me use a different color so we don't get confused here. So multiply this top and bottom by 15. This top and bottom multiply by 5. This one multiply by 3. And this one you're going to have to multiply by 15. So if you want to rewrite this like I was doing earlier to spread it out to make it look a little bit better, you totally can. Maybe should have done that for this one since there's a lot of steps, but either way we have 15 times c is 15c over 15 times 1 is 15. Now we have plus, not a minus, 5 times negative c is negative 5c over 3 times 5 is 15. And 3 times c is 3c over 3 times 5 is 15. And 26 times 15 is 390 over 15. So we got kind of a bigger number, but that's okay. It'll work out. We can use a calculator, so it's not that bad. Since all of them are over 15, now we can put the numerators for our equation. We can forget about the denominators. Combine like terms. These are all c's, so I have 15 minus 5 plus 3c ends up being 13c is equal to 390. Divide both sides by 13. C is equal to 390 divided by 13 is 30. Moving on, number 5 then. Now this one we have a binomial in the second one, the second numerator. But again, don't make this more difficult than it has to be. It's the same thing we've been doing. First thing, I see a minus, so I'm going to change it to a plus and put that negative in my numerator. We'll get some more of those a little bit later. And it looks like 6 is going to be the number that we want. So I need to multiply this top and bottom by 2, this top and bottom by 3, and this one it's already 6, so we don't have to multiply the top and the bottom by anything. So 2 times 2x is 4x over 2 times 3 is 6, plus 3 times -1 is -3 over 6 is equal to 2x plus 5 over 6. All those denominators are the same, so we can forget about them. Just list out our numerators. Oops, supposed to be a 2. 4x plus 2x is 6x. Whoops, almost did that one wrong. We can't combine those because we have to cancel. They're on opposite sides of this equal sign. Almost made a rookie mistake. So I'm going to subtract 2x from both sides first. That was close. I was just testing you. 2x minus 3 is equal to 5, so you add 3 to both sides. 2x is equal to 8. Divide by 2, we get x is equal to 4. So those aren't so bad with those numbers in the denominators. We're going to move on to monomials and then binomials or trinomials. But first, let's have a couple that you guys do on your own. Hopefully you guys know the drill by now, but go ahead, hit pause, do this on your own. If you get stuck or when you get done, hit play and then watch me go through it. But make sure you're doing this on your own, because if you're just going to be watching me do it and copying down what I do, you're not going to learn from it. So make sure you do this one on your own, then hit play to check your work. So for this one, it looks like the common denominator is going to be 8. Again, I'm going to make that numerator into a fraction. And it's kind of hard to do with this one since it's a minus and that wasn't a fraction. But I'm going to make that a plus -x over 1 is equal to x over 8. Now again, for this stuff, it's not the most important to change that minus to a plus, but I think it's going to help since we've been doing that, and it's definitely going to help when you start getting a binomial in that numerator there. So I want to change all my denominators to 8, so I'm going to multiply the 2 by 4, and I'm going to multiply the 1 by 8, which means you have to multiply the numerators. So we get 2 times 1 is 2 over 8. 8 times -x is -8x over 8. And x over 8 doesn't change at all because we didn't have to multiply it by anything. It already was 8. So the denominators are all the same, so we don't have to worry about those. Let's just look at our numerators. Subtract 2 from both sides. We have -8x is equal to... Oh, guess I shouldn't have done that. Sorry, since these are both x's, we're going to combine our x's first. This would just be x minus 2. That doesn't really help us. We could get the answer that way. It's not that I did it wrong. There's just a quicker way. I didn't realize this was an x over here. So we're going to combine our x's first. So we're going to add 8x to both sides. So we have 2 is equal to 9x. Then a lot of people make this mistake. They divide by 2, and they get their answer to be 9 over 2. But no, we're getting the x by itself. So we have to cancel the 9, not the 2. So we divide both sides by, oops, I said not 2 and I wrote it down. Divide both sides by 9. We end up getting x is equal to 2 over 9. If you made that a decimal, that is fine. I can live with that. And again, number 7, I want you to do this on your own. So go ahead, hit pause, do it on your own, and then hit play and check your work, please. With this one, I'm going to make all the denominators 12. So I'm going to multiply this one, top and bottom by 2, and this one, same thing, top and bottom by 2. So we have 3x minus 2 over 12. Minus, so again, I'm going to change that to a plus and make that 1 a negative. Should have done that earlier. So 2 times -1 is -2 over 12. And 2 times 1 is 2 over 12. So all our denominators are the same. That's good. So I get 3x squared, or sorry, 3x minus 2 plus -2 is equal to 2. I have -2 plus -2. That is -4 is equal to 2. You really don't have to put that plus sign since it's a negative, but that's okay. I like it there. I think it works really well. It's the same every time. Add 4 to both sides. We have 3x is equal to 6. Divide both sides by 3. X is equal to 6 over 3 is 2. So hopefully that's what you're getting for those two. If not, go back, rewind, watch some of the other examples. Make sure you know how to get those common denominators, because if you don't, these monomials are going to be a little bit difficult because they're just one step harder. Now, one thing I did highlight over here is these are all fractions with variables in the denominator. Over here, none of the variables were denominators. But here, if x was 0, it wouldn't work because that's in the denominator. Over here, if x was 0, it wouldn't work because you get 0 in the denominator. So really, excluded values still apply. I just want to make sure I say that. But again, it's only if we ask for them, and I don't think we're really going to be asking on these types of problems because there's so many fractions. But I want to make a point to take a second to say that excluded values still definitely apply because now we have fractions with variables in the denominator. So just like we did before, we were trying to find a common denominator or at least common multiple, and we have 2x, 2, and x. Well, with monomials, we try to get the numbers to be the same, so let's try to get them all to be 2, and then we all have to have an x with ours. So this first one, I need to multiply the top and the bottom by 2 to get 2x, and this other one, I need to multiply the top and the bottom by x. So I get 2 over 2x plus x squared over 2x, x times x, is equal to x plus 4 over 2x. So all the denominators are the same, that's what we wanted, so now we can kind of forget about those. We have 2 plus x squared is equal to x plus 4. Now we have a quadratic, so we have to solve with a x squared in there. The way I'm going to do this is, if this is a positive x squared, you always want a positive x squared. So if it's a negative, take it to the other side to make it positive. Since it is positive, I'm going to take everything else and put it on the same side as that x squared. And you'll see what I'm talking about when we have a negative here, not 2 on. So I'm going to subtract 4 first. Combine our like terms. 2 minus 4 is negative 2 plus x squared. Then I'm going to subtract x. So we end up with, and I'm going to put this in a different order. Well, I'll just do this first. We have negative x minus 2 plus x squared. So we're not used to seeing it in this order when we factor and do different things and different solving things with that quadratic formula. So the x squared comes first, then the minus x, then the minus 2. And you could have done that kind of here at the beginning when you were solving some things. But that's a quadratic. We got everything on the same side, but now we have to solve that. So let me rewrite this over here. X squared minus x minus 2. Use your x factoring. There is no leading coefficient, so the good news is we can do the shortcut. Factors of negative 2 that add up to be negative 1 are negative 1 and 2, and the 2 has to be negative. So it's x plus 1, x minus 2, but this is all equal to 0. I should have put that up here. This is all equal to 0 because we're solving. We're not just factoring, we are solving these. So what would make 0 over here? Well, what would make this part 0? Negative 1. What would make this part 0? Positive 2. So your answer is negative 1, positive 2 for this one. Now, one thing you're going to want to check, though. I said you don't have to worry about the excluded values, but when you get your answer, go ahead and check to make sure your answer actually works. You don't have to tell me your excluded values, but go through and just make sure negative 1 would still be fine for both of these and 2 would still be fine for both of those. I don't know, on the test you'll maybe have one of them that trick you like that, so don't stress too much about it, but take an extra second, plug both of those in, make sure those aren't one of your excluded values, make sure it works for both of them. And I don't know if any of them on these notes are like that or not. When I did the notes earlier today, I forgot to look for that, but it's something I want to make sure I remind you, because on the I-step, who knows? They could try to pull a fast one like that. And maybe, like I said, on the test, maybe there's going to be one like that. But don't stress too much. You're not going to fail the test if you don't remember that. So let's try this one. So we have a 3x, a 3, and an x squared. So we want all those to match. Well, this one is an x squared, so we need all of them to have an x squared. So multiply this one by x, multiply this one by x. That's good. And then the other ones are a 3, so we're going to end up getting a 3x squared is what our common denominator is going to look like. So we already have the x. Oh, this one needs an x squared. sorry, 3x squared. So this one has 3x squared. This one now has 3x squared. This one you have to multiply by 3, top and bottom. And almost forgot, make sure you do top and bottom for these two as well. And that minus I'm going to change to a plus. So from here, for these, I will say it does help a little bit to write down what your common denominator is before you go in there. I just did that one without doing that, and it's a little bit easier if you list what your common denominator is first before you do anything. So now we have 11x over 3x squared plus negative 1 times x squared is just x squared over 3x squared. Negative 4 times 3 is negative 12 over 3x squared. So we have our 3x squared in the bottom. Those all match. So set our numerators equal to each other. 11x plus negative x squared is equal to negative 12. Now, this is what I was talking about on the last slide. This negative x squared, we've never factored with a negative x in front. So negative x squared plus something x, blah, 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 blah. We've never done that. So let's not start now. Let's make that negative x squared into a positive by just putting it to the other side. So if you add x squared to both sides, now we have 11x is equal to x squared minus 12. And now all we need is the 11x over there, so subtract the 11x. We end up with 0 is equal to positive x squared, that's what we wanted, negative x plus 12. So we have x squared minus 11x plus 12. And we're doing our x factoring for this. So factors of 12 that add up to be negative 11. I have 1 and 12, but the 12 is negative, and there's no number in front, so we can do our shortcut. X plus 1 times x minus 12 is equal to 0. So x is equal to negative 1, because that's what would make this 0, and x is equal to positive 12, because that's what would make this 0. Then take a quick second, go ahead and check. Plug negative 1 into your denominators. 3 times negative 1 is good, negative 1 squared is fine. Plug 12 into your denominators, make sure those aren't the excluded values, or make sure those don't give you an undefined fraction. So moving on, number 10, and then a couple of them that you guys are going to do on your own. We have 2x, 3x, and this one is just 1. And again, we have a minus, so I'm going to change that to a plus and put my numerator as a minus right away. I think that helps. And then let's see, between 2 and 3, our common factor or our common denominator would be 6. And then between x, x, and 1, well, it's going to be just x. So I want my denominator to be 6x. So multiply this one by 3. 3 times 2x is 6x. That's fine. Top and bottom. Multiply this one by 2. That'll give you 6x. And this one I'll have to multiply the top and the bottom by 6x. So, again, writing that out helps a little bit. I think that's a good idea. I should have done that from the beginning. So 3 times 3 is 9. Plus 2 times negative 5 is negative 10 over 6x is equal to 12x over 6x. Now that 6x is all we have in our denominator, that's 9 plus negative 10 is equal to 12x. Again, if you put 9 minus 10, that would work. 9 plus negative 10 is negative 1 is equal to 12x. And again, a lot of people divide both sides then by negative 1, say their answer is negative 12. But no, that'd be canceling out the negative 1, not the 12. We want to cancel out the 12. So divide both sides by 12. Get x is equal to negative 12. So some of them will work out really nicely like that where they're not quadratics. Again, still, I just did that same mistake. I just told you not to do that. I just did it. Sorry, the answer is not negative 12. It's 1 over negative 12. Kind of like the thing I just wrote down over here. Sorry. So that's our answer. Plug it in to check to make sure it works. Again, plug it into your denominators. This one doesn't even have a denominator when we started, so we don't have to worry about that. But that does work. That doesn't give us any zeros in the denominator, so that's our answer. Now, a couple of them you do. Make sure you hit pause, do this on your own, then hit play to make sure you did it right. Now, this one's a little bit different because we don't have 2 of them aren't fractions, so we put them over 1. but then our denominator is just x. Well, to get a common denominator, if it's just x, let's make all of them just x. So I'll multiply the top and the bottom by x. That would give me x for that one. Multiply the top and the bottom by x for that one. That would give me x. So we have x squared over x plus 6 over x is equal to negative 5x over x. So now all my denominators are the same. So that means we have x squared plus 6 is equal to negative 5x. Again, our x squared is positive. That's what we need to happen. If it wasn't, we need to take it to the other side. Since it's positive, we'll just leave it on that side. We'll take everything else to that side. X squared plus 5x minus 6 is equal to 0. And just like we did before, that means we have a quadratic. You guys should be pretty much experts at solving and factoring now. So I have factors that multiply to be negative 6, that add up to be 5. That is probably 1 and 6, and the 1 is negative. Is that right? Make sure you double check, because a lot of people put 2 and 3 for this one. So negative 1 times 6 is negative 6. Negative 1 plus 6 is 5. Like I said, a lot of people do 2 and 3, but that would be positive 6. So if I made one of them negative, now all of a sudden that doesn't add up to be 5. But that's one of those tricky ones that a lot of people miss. So double check your work. Since there's not a number in front, we can do our shortcut. X minus 5 times x plus 6. And that means we have x is equal to positive 1, x is equal to negative 6. So far, we haven't had any leading coefficients. So we've been able to do it the easy way on all those. And last thing, check. Make sure these both work. Plug them into your denominators. We only had one denominator, and it's just x. So 1 would be fine, 6 would be fine, or negative 6 would be fine. We're just plugging them in to make sure we don't get 0 for that denominator. All right, moving on to the next one. And it might actually not be a bad idea. I was just thinking this. I told you you don't have to find the excluded values, but maybe you should do that right away. Find the excluded values, because we can't have 0 in the denominator, and that way you can just look at your answer. Did I get that for any of my answers? Might not be a bad idea. I'm not going to stress too much over it, because like I said, it's not going to be a huge part of your test. Just make sure I remind you. We have another minus. I'm going to change it to a plus, make my 3 a negative. And we have a 4x, 4, and x. So hopefully this is a little bit obvious, but we obviously need a 4, and we need an x. So if I took this one times x, we'd be fine. This one times 4, then we'd have 4x in all the denominators. So 1 over 4x. Negative 3 times x is negative 3x over 4x. And 7 times 4 is 28 over 4x. So we end up with, since all the denominators are the same, 1 plus negative 3x is equal to 28. Subtract my 1 from both sides. Negative 3x is equal to 27. Divide by negative 3. X is equal to negative 9. Again, you can double check, plug those into your denominators, but I'm not going to worry too much about that right now. So now we're going on to what I would say is the hardest part about this lesson is doing polynomials in the denominator, not just monomials. So this is what I was talking about earlier, where if you get an answer of negative 2, we don't want that because that would make 0 for our denominator here, and that wouldn't work. So again, maybe you should list out, maybe listing out your excluded values would help if you list those out first. I don't know, that's up to you. But let's go ahead and solve this. Make sure this is the same rules as finding normal common denominators when we're adding and subtracting, where the first thing you're going to do is you're going to factor your denominators. Once your denominators are factors, then we need to get all of those to match, all 3 of them. Good news is this one we don't need to factor anything. All of our denominators are already factored. So this one is an x, and this was an x plus 2. Now be careful, because in the last one, if we had x and 2x, all we had to do is multiply this other one by 2. But now we're not multiplying, it's adding. We're adding 2 here. So that's 2 different things. This is x plus 2, and this is 1. So to get them all to match, we're going to have to get them all to be x and x plus 2. Which means I would probably, since they're a little bit bigger numbers, not bigger, but like since they're binomials, they're a little bit longer to write. I'm going to write this over here to make it a little easier, just give myself some more space. It's a 7 over x plus 2 is equal to 9 over 1. So this is that common denominator we're going to get, so I need to multiply this one, top and the bottom, by x plus 2. This one I need an x, so multiply top and bottom by x. And this one I need to multiply all of it times x plus 2. Top and bottom, that was close. So this first one I have 15 times x is 15x. 15 times 2 is 30 over x times x plus 2. Plus, now this one, again, you might want to put the x in front, might be a little bit better to distribute. But 9x times x is 9x squared minus 7x over x times x plus 2 is equal to, and then we have 9 times x. Let me do this a different way. So don't distribute, don't do what I almost did where you distribute like this. That's not going to work very well. Instead, I'm going to take the 9 and the x multiplied together first. So that means I have 9x times x plus 2, and then distribute that. 9x times x is 9x squared. 9x times 2 is 18x over x times x plus 2. Now you could have done it the other way. You could have multiplied these two first and gotten x squared plus 2x and then multiplied that by 9. Doesn't make any difference. The whole idea is that now we have all the denominators are the same, so now we can set our numerators equal to each other and solve. 15x plus 30 plus 9x squared minus 7x is equal to 9x squared plus 18x. So put all our like terms together. I have a 15x and a negative 7x, so that's 8x. Guess I have this 9x squared. I could have put that first. Doesn't really matter. Then 30 is the only other thing on this side. And then we kind of lucked out a little bit on this one, because now when we put our like terms together, I'm going to subtract 9x squared from this side and from this side. And we lucked out because that means they both cancel. We don't have any x squareds left. So we have 8x plus 30 is equal to 18x. I'm going to subtract 8x from both sides. Running out of room here. We have 30. Do that in red. That's not what I wanted. Sorry. 30 is equal to 10x. Divide by 10. Yet x is equal to 3. Again, you might want to plug it back into check, but 3 is fine. That will work for all of them. Now, with this, again, the biggest thing you have to remember is that these are not monomials. With monomials, that's what we just did, but when we have a binomial, we have two terms here. It's not multiplying, it's adding and subtracting. That's when we have to get them to match this way. So we had to multiply x plus 2. I didn't just multiply it by 2. So make sure you remember that. And I would, if I were you, I would rewrite things to make sure there's a little bit more space. Because before, you could kind of fit it in here. Since we're just putting an x or a 4, just something real simple. But now all of a sudden we're putting in an x plus 2 on the top and the bottom, or an x times x plus 2 on the top and the bottom. I would put it with some space and make it a little bit easier for you. So this one actually looks a little bit, ends up being a little bit not too nasty, but it's kind of confusing at the beginning. And the reason is because, remember on the last one I told you, the first thing you want to look at is see if you can factor any of those denominators. That's the first thing I want you to look for. And this denominator is a difference in squares. 1 is 1 times 1. So this one we can break down into b plus 1 times b minus 1 for that denominator. Now again, I'm going to write this with a little bit more space. I have 1 over b plus 1. Plus 1 over b minus 1 is equal to 2 over b plus 1 times b minus 1. So to get all these to be the same, this one needs a b minus 1. This one has a b minus 1, so it needs a b plus 1. Top and bottom, same thing we've been doing. This one has a b plus 1 and a b minus 1, so we're good to go. Now all of them have b plus 1 and b minus 1. So on the numerator for this one, we have b minus 1. Over here, b minus 1 times b plus 1. Our numerator is b plus 1. And over here, we already had the b plus 1, b minus 1. So the numerator for this one just stays as 2. So now all our denominators are the same. So we have b minus 1 plus b plus 1 is equal to 2. So combine our like terms, b plus b is 2b. Negative 1 plus 1, those cancel, so that's kind of nice. So that's 2b is just equal to 2. Again, negative 1 plus 1. Cancel each other out. So divide both sides by 2. We get b is equal to 1. Now, this is the one I was talking about where, again, if you don't see this or if you don't realize this, it's not a huge deal. You won't fail the test by any means. But I got b is equal to 1. But if you look and sub that in here, it worked well for this one. 1 plus 1 is 2. So if you plug it in, you get 2 for this denominator. That's fine. But if you plug it into this one, 1 minus 1 is 0. This one, too, b squared, 1 squared minus 1 is 0. So this one actually, and if you put this, again, you'll get most of your points. I'll maybe count half a point off, and you'll maybe have 1, maybe 2 on the test. Probably, maybe not any. But if you want to check that over, that actually is no solution, because the only solution we got would make it undefined. So be careful with that. Again, if you are just looking to pass the test, you're just trying to work hard just to get that D minus, then don't even worry about that. If you are okay getting a C or a B, then don't even worry about that. But if you're one of those people that really, really want to do their best and try to get an A or try to get all of them right or whatever you need, then you can check that. Then you can worry about that. But like I said, maybe half a point on the test, if that. At most, I guess maybe 2 of them are going to be on the test like that, and you miss 1 point. But again, I would not lose sleep over it. And number 15 then. 15, we have a little bit more of a factoring problem at the beginning here, because I need to factor this first one. So factors of 15 that add up to be negative 8. 3 and 5, but both of them have to be negative. And again, double check. Negative 3 times negative 5 is 15. Negative 3 plus negative 5 is negative 8. So this is x minus 3, x minus 5. So we have that, and then we have an x minus 5 and an x minus 3. So obviously our common denominator is going to be x minus 3 and x minus 5. So again, I'm going to rewrite this to give myself some extra space. 7x plus 3 over x minus 3 times x minus 5 plus 3x over x minus 5. I like to put them in parentheses. That'll help later. And negative 1 over x minus 3. So we need all of them to match. This one has an x minus 3 and an x minus 5, so they all need an x minus 3 and an x minus 5. So this one needs an x minus 3, and this one needs an x minus 5. Now, if you're getting confused at why I'm multiplying by the x minus 3 and the x minus 5 on both of those, go back and rewatch the lesson over adding and subtracting where we found common denominators, because we talk about that in a little bit more depth than this. But right now, I'm assuming you guys know that because you just did that last lesson. So now we can go through. This numerator didn't change at all. X minus 3, x minus 5, plus 3x squared minus 9x over x minus 5 times x minus 3 is equal to negative x plus 5 when you distribute that one over x minus 3, x minus 5. So again, good news, we all have our common denominators there. So I have 7x plus 3 plus 3x squared minus 9x is equal to negative x plus 5. So combine some like terms. We have 3x squared in front. 7x minus 9x is negative 2x. So we just have a plus 3 left. is equal to negative x plus 5. And then I'm going to get, this is a quadratic, sorry, that's my train of thought. So I'm going to get everything on the same side because that's a positive. So at x, we have 3x squared minus x plus 3 is equal to 5, and subtract 5. I end up with 3x squared minus x minus 2 is equal to 0. But again, the bad news is we're not quite done yet. We have to factor that and solve. The worst news is we can't take the shortcut on that one. So let's see where I have some room to write this out. Let's do this. Let's put an arrow here so you guys can see that. So we have 3x squared minus x minus 2 is equal to 0. So if we do my x factor, I'm looking for factors of negative 2 that add up to be positive, or sorry, see, I almost missed that because I almost did the shortcut. Make sure you're paying attention. It's 3 times negative 2. We've been doing it a lot where I just say, oh, well, it's negative 5 and it's this last number. You should always take the first times the last, negative 6 over negative 1. So two numbers that multiply to be negative 6 that add up to be negative 1 are 2 and negative 3. But again, that's not, you can't just skip to your answer now. We have to do it the long way. 3x squared and negative 2. Our first number and our last number don't change. I have a plus 2x and a negative 3x. And now we do our factor by grouping. So we'll put those together. Make sure this minus sign stays with that 3. We'll talk why in a second. And I can factor out an x. That leaves 3x plus 2. And this one, since that's a negative, we factor out a negative 1. At least you have to factor out a negative number. If you can't take anything else out, you need to take out a negative 1. That leaves positive 3x plus 2. So we have x minus 1 and 3x plus 2. But again, not our answer. We're not just factoring. We are solving by factoring, which means we have x is equal to positive 1. And this one, if you can't solve this one in your head, go ahead and solve it on paper. Subtract 2, divide by 3, so we get x is equal to negative 2 over 3. So occasionally you'll have a question like that where it does take a little while. Again, you might want to take those answers and plug them in your denominators to see if it works out like the last one. But again, I really wouldn't stress out. I'm glad I saw one that I could show you this example, but I don't want you guys to get scared of that. That's not going to be a huge deal. Actually, it wouldn't surprise me if none of that would show up on the test. None of those. Excuse me. So now we have another you do. So go ahead, pause it, do it on your own. This one's really nice because it already factored for us right here, so be careful with that. But it's, yeah, be careful with it, but they already factored, so that's good news. So go ahead, hit pause, and do this one on your own. So first thing, this is a minus, so I'm going to change it to a plus and change that to a minus. Guess we didn't have too many of them where that mattered at all. So I was looking over this one. I feel like, did this skip one? Yeah, they put all my work. I hate when that happens. Sorry. Let's say number 16. They put all my work for number 15 on number 16. I don't know how they do that. Give me a second here. All right. Sorry. If you already did that one on your own, I apologize. You can skip back and watch this one. This one, it reminded me because I remember this one is a minus. So this one is one of the first ones that it really helps to make sure that's a plus, and then change this one to a minus and this one to a minus. That really makes this one a lot easier. Again, factor everything possible. So I can factor out a 2, then we have x plus 4. This one's, or sorry, y plus 4. This one's y plus 4, y minus 4. And this one's 2 times y minus 4. So we need to get all these to be equal to each other. And so what do all of them need? Well, this one could use a y minus 4. So we'll multiply the top one by y minus 4. This one almost has everything, but it doesn't have the 2. So multiply the top and the bottom by 2. Yeah, let's go ahead. I've been doing this the whole time. Let's rewrite this one. So we have 10 over 2y plus, 2 times y plus 4. And we just said we're going to multiply that one, the top and bottom, by y minus 4. Then we have plus, and we have negative 7y minus 8 over 2 times y plus 4 times y minus 4. And I'm going to need to multiply the top and the bottom by 2 to get that. So I guess I should have, this one was just y plus 4, y minus 4, so we need to multiply by 2. And that's equal to, we have, 2 times y minus 4 and negative 8. So I need to multiply this one, the top and the bottom, by y plus 4. So now our denominators are all the same. Our denominators are all 2, y plus 4, y minus 4. So the numerators now we multiply out 10 times y minus 40 plus 2y plus 4 times y minus 4. And we have 2 times negative 7 is negative 14y. 2 times negative 8 is negative 16. Is equal to negative 8y minus 32 over 2 times y minus 4 times y plus 4. Now this one seemed like a pain so far, and it kind of was. Not only did it give me a technical difficulty that I had to work through quick, but it seems hard because we have a lot of factoring, all these. But now if you look, now all the denominators are the same. This one's not even a quadratic, so we don't have to factor anything now to solve. We had to factor the denominators, but from here on out, we have 10y minus 40 minus 14y minus 16 is equal to negative 8y minus 32. Combine your like terms, we have negative 4y plus 56 is equal to negative 8y minus 32. Combine your like terms now. Cancel those. We have 4y plus 56 is equal to negative 32. Subtract 56. 4y is equal to 32 minus 56 is negative 88. Divide both sides by 4. You get negative 22. Y is equal to negative 22. So, sorry about that. I didn't realize that my PowerPoint was going to do that. It does that sometimes, and it's really ridiculous. I don't know. It literally put all my writing that was supposed to be on this slide on this slide. Anyways, so you guys see what that is. So this one, again, the biggest thing was that it had this negative right here. That's really why I wanted to show you that. And again, as much as it was kind of work to get the denominators to be the same, then once you got those to be the same, the numerators weren't really that bad, just combining like terms and solving. So now, go ahead and do this one. If you already did this one, I apologize. Now you can go and watch this. So, without further ado, this was a minus, so we change it to a plus, change that to a minus. Now we need to get all our denominators to be the same. I'm going to rewrite this, plus negative 1 over x is equal to negative 4 over x times x plus 2. So we need our denominators, and it looks like this has to be our common denominator. They all have to match. So this one needs an x. This one needs an x plus 2. This one has both of those, so now they all match. So we have 2x over x. Well, you don't have to multiply that, sorry. You can multiply that, x squared plus 2x if you want. I'm not going to worry about it because that's a little extra work. Plus negative x minus 2 over x times x plus 2. Multiply that out. And this one didn't change. Negative 4 over x times x plus 2. And like I said, all our denominators match now. That's the whole idea. So we have 2x minus x minus 2 is equal to negative 4. Combine your like terms. That's x minus 2 is equal to negative 4. Add 2. So that one's a really good one. That's a good one to start with for your first one doing this. So that one ended up x is equal to negative 2. Again, if you have that, that's totally fine. Now, just to make sure, if you would take that and plug that back in, you'd end up getting 0 for that denominator. So technically, this one is no solution. But again, if that confuses you, don't even worry about it. Move on. Wanted to tell you why that is, but it's one of those things. It's not hard to do, but it's hard to remember to do. And like I said, maybe 1 or 2 on the test, and it's half a point. So I'm not going to cry. Our last test had 85 points on it, and if you, 1 point out of 85 didn't really hurt anybody too much, so don't fret too much. And last one, number 18 for this one. Again, we have another minus, so I'm going to go ahead and change that to a plus, and that's going to change this negative 3 to a positive 3. And I'm going to factor this out. Factors of negative 12 to add up to be negative 1 are 3 and 4. The 3 is positive, the 4 is negative, so x plus 3, x minus 4. And again, I'm going to rewrite this. I think that's easier. X plus 3, then we have plus 3 over x minus 4 is equal to 2x minus 2 over x plus 3 times x minus 4. I think rewriting is nice because it gives you extra room, and like I said, since we factored that, it's kind of nice to write that in there. So we want all these to match, so this one doesn't have an x minus 4. This one doesn't have an x minus 3. That's supposed to be a 4. I don't know how I messed that up. That looks very ugly. X minus 3 plus 3. And luckily this one has both of them, so we're good to go. So our denominators then are all the same. X plus 3 times x minus 4. And the top we have 2x minus 8 plus x plus 3 times x minus 4. We have 3x plus 9 is equal to x plus 3 times x minus 4. And this part didn't change at all. So all those have the same denominator, so we have 2x minus 8 plus 3x minus 9 is equal to 2x minus 2. 3x and 2x combine to be 5x. That look a little bit more neat. 5x. Negative 8 and negative 9 is negative 17. Is 2x minus 2. So just solve this like normal. It's not a quadratic, so that's kind of nice. Good one to end on. Add 17. 3x is equal to negative 2 plus 17 is positive 15. Divide both of those by 3. Run out of room. X is equal to 5. So x is equal to 5. Again, if you want, plug it back into check, but this one does work out. So that is your answer. So that was section 8.6. That was solving. Again, really the hardest part about this is the same thing that was hard about the adding and subtracting expressions, because you find a common denominator, which means you have to factor to get there. I apologize for that little mishap with the technology over on this last slide. The fact is, it's really hard to edit these, and I don't want to re-record a whole thing for that, so I apologize that it took an extra couple seconds and it maybe mixed you guys up a little bit. But the good news is you can pause, fast forward, rewind, whatever you need to do to get back on track. So if you have any questions, feel free to email me or ask your sub. Thank you.